All right. So thank you, Gary, and good morning, good afternoon, and good evening, ladies and gentlemen, on all the audiences. My name is Yuxi Wang, and for somebody who already know me, I have an English name called York. So it's easy to remember me that you can just call me York directly, and when you ask the questions. So before starting the presentation, I would like to do a short introduction for myself. I used to work in the oil and gas industry in the upstream section. And then I entered the water industry back in 2014. And now my research areas are mainly focusing on the water loss detection and location pinpointing, and also the water loss management, the entire regime. So to be honest with you, I actually have a script. I got my script, but just to give you a more natural presentation, I decided to keep it down because I haven't done this sort of English presentation for almost 8 years. So I will try my best. And if you have any questions, please write it in the chatting section, and I will answer after everything is over. So today I'm going to talk about the knowledge of leak noise and some case studies in China, including the active leakage control and also the performance-based control case studies. The reason why I'm trying to talk about the leak noise and also the basic methodologies and tools during the leak detection is that because when we do all sort of ALC projects or anything related with water loss management, as you know the water balance, we have the physical losses, we have commercial losses. To control the physical losses, because the hole is actually there in a pipe, so you have to find the hole, and you have to find the hole and dig it out, and also to fix up the hole. So if your team or your engineering team does not have any idea how the leak noise is created, like the mechanisms, how the leak noise occurs, how to differentiate between the fake noises, and also the background noises between and with the real leak noises, then it's going to be a problem that you cannot really find the right leaks, or you maybe find lots of fake leaks, or we can say it's a dry hole. So in my presentation, there's going to be 4 areas to be covered. I'm going to talk about the knowledge of leak noise first, and then some conventional and unconventional techniques we used in China, and the tricky situations we encountered during the detection activities. And at last, we will have some case studies on the Chinese water utilities. So first section, the knowledge of leak noise. So what's the component of a single leak noise? In fact, you can say it's kind of like a piece of music that mixed up with all kinds of frequencies, from low frequency to middle frequency to the high frequency. And the other way, as you can see from the diagram, it's composed by 4 parts. So you will have some vibration from the pipe, and you will have some water flows, and you will have the impaction when the water jet comes up from the hole to inject the background soil. And also at last, you will have some friction when the water jet is coming out from the hole. The friction between the hole and the water body itself, it will create some noises. So basically, we have 4 types of noises that mix up together to create a leak noise. And I'm going to show you 3 types of real leak noise One is from the cast iron pipe. The second one is from the PVC pipe, and the third one is from the lead pipe. So I'm just trying to turn down the noise, then people can hear it clearly. So that's the cast iron pipe, and this is the PVC pipe. And at last, let me show you the lead pipe. So from here, you can already know there's some differences between the pitch, between the cast iron pipe, especially from the metallic pipe and non-metallic pipe. You can hear like the metallic pipes have higher pitch, and the non-metallic pipe is more low pitch, and it sounds quite, in the low frequencies. For the lead pipe, it's in China. To be honest, there's not many application of lead pipe already, because it's already being replaced by the ductile iron pipe. But in Japan, there are still some old age lead pipe still using, but most of them are also replaced already. So to find the leak point, obviously you have to use all kinds of tools to help you listen and find the leak noise. So there are many parameters that will have a main impact on the leak noise. So I list three main parameters. There are water pressure, and there are the pipe material, and the third one is the bureau depth. Those three parameters are as far as I know, it's like the most important three parameters that can affect the leak noise. So from the left top diagram, as we know, the phi at N1 equation shows that when the pressure is getting higher, the leak rate is getting higher. So we will have more or less a proportional relationship between the water pressure and also the leak rate. And it's same applies with the sound intensity and the water pressure. So as you can see from this diagram, you will have a very steep gradient of increasing from 0.1 Pascal to 0.3 Pascal. And the leak noise will getting very quickly become very louder. And until we reach to 0.4 to 0.5 megapascal, it's getting slowing down. But overall, you can see the sound intensity or the loudness of the leak noise is getting louder when the water pressure is getting higher. So for the pipe material, to simplify, the metallic pipe will have a longer propagation distance, and the non-metallic pipe will have a shorter propagation distance. So for PE pipe, you can see that the propagation distance is very short, and when it propagates from 0 to some certain distance, the leak noise level will get into almost 0. But for the steel pipe, it can get very, very long, probably a couple of tens of meters, or maybe even 100, 200 meters long. So when you detect a non-metallic pipe, you have to be very, very careful what kind of tools and what kind of the filter you're going to use. But I will not really talk about this during this presentation. If any of you guys have any questions about this, you can leave me a message on the chatting section. So also for the bureau depth, the deeper the pipe bureau, the more attenuation of the leak noise, or the noise energy will attenuate, because when the noise from the hole and it propagates vertically to the ground surface, the energy will be absorbed by the background soil and all other materials which is buried underground. So which means the shallower the depth, it's easier for you to detect a point, to pinpoint a point. And for the deeper pipe, you will be harder to get to find the leak point. So, and also from this diagram, you can see that the higher frequency of the leak noise, the more attenuation will be, and compared to the lower frequencies. So when we try to pinpoint leak location, we will always encounter two kinds of noises as well. The first one is the fake noise, and it will happen anywhere around any world. So at least like 3 fake noises. The first one is the power transformer, which is quite a common situation when we're doing the detection activities in China. And we have water flow, and sometimes we can hear the water meter. And also there's a sewage sound. If the sewage is quite close to the water mains, they also will have, you can also listen the sound from the sewage. So let me just show you the sound of each one. So this is quite common in China when we doing the detection work in the living district, where we have lots of buildings and apartments, and they will have lots of the air conditioner and other things, including the power transformer on the street. When we try to use the ground microphone to pinpoint the leak noise, we can actually hear exactly the same noise like this. But it's easy to cut it off, because sometimes the main unit have the function, like the special filter, to cut off this kind of low pitch. So it's okay. So second one is the water flow. It's mid to high. Well, it's actually mid pitch. The water flow, especially during the high demand, the high demand time, like for example in China between 5 to 6 p.m. when lots of people coming home and doing some cookings and they use lots of water, the water flow will become very strong, and sometimes when they go through the valves, it will create a very similar sound, like the real noise. So the rookies from the leak detection will sometimes confused by the water flow sound and also the leak noise. So this is one of the tricky fake noises that we encounter during the leak activities. So the third one is the water meter. So you can clearly hear the click of the water meter, but this is very common in the detection work. But it's also easy. I think it's easy to differentiate between the real noise and this click sound. But this is like one of the common situation we have during the work. So the last one is the sewage. It's not really clear as the water flow, but there's one time when I did a detection on the street, the sewage flow is so loud that confused me like, okay, there must be a big leak on the water main, but actually it was the sewage, because when you hear the sewage sound, it's quite similar to the leak noise, but in the same time, you can check on the street if you see any sewage chamber or something near the water mains to, to eliminate one of these options. So this is like the 4 fake noises I listed on the presentation. In the real situation, there are more fake noises that we have during activities, but those four noises are kind of the typical fake noises we have in China. So the second one is the mixture of leak noise and background noises. I have no idea in other countries, especially in the European countries, how the background noise level would be. Because when I was studying in UK, of course, there are the streets are relatively quiet. But in China, like you see from the diagram on your right side, we usually do work during the daytime, especially in the traffic jam time, and sometimes even in the night after 12 o'clock, or between theoretically between 2 or 4 o'clock in the morning. The most quiet time, the streets are still noisy in some certain area. So we usually hear the leak noise also with the background noises all together. It's always like that. We don't really hear any like pure leak noises at night. It's always have some dog barking or people walking on the street, or some motorcycles coming through, all kinds of situations. So let me just show you 4 mixture of leak noises and the background noises to give you some idea how the sound would be like under this certain situation. So the first one is the vehicle passing over a leak point. So you can hear that the stronger noise of the stronger leak noise, it's clear than the cars driving through. The situation between, all right, somebody just leave a message. Okay, let's continue. So how to find a leak when there's lots of traffic jams? This is like one of the common tricky situations what we have, especially in China, because we've done lots of daily work. So the sound I just played to all the audiences, it's one of like the typical mixed up of the leak noise and the vehicle noises. But when you start getting familiar with the leak noise, you can realize that the leak noise it's continuous. It's a continuous noise rather than the vehicle one. Because the vehicle is more or less, coming one car and then a second car. It's not that continuous. So you can still differentiate that the leak noise is continuously leaking out because the water is leaking out. So the noise is continuous. And then you will find that in your head, the leak noise is always there. Whatever, how many cars driving through, it's always there. So you are able to pinpoint the leak. So the second one is the leak near the sewage manhole, just like what I showed you in the last slide. It's a situation near the sewage. So it's almost, the 2 noises are almost combined together. It's hard to differentiate already if there's a leak near a sewage, because sewage is also water. It's kind of water flow, and leak is kind of water flow. So the noises they create in both situations, there are some frequencies in common. And then when there are some common frequencies, they will combine together so that you cannot really differentiate between the leak noise and the sewage, the noises from the sewage manhole. At the same time, you can, if you listen very carefully, there are some gravity flows of the water flow, you know, like the waterfall. So this situation is also very tricky when you check the leak points near the sewage manhole. So when you hear this kind of noise, do not rush to an answer. You have to look on the street and check if there are any sewage near your water mains, because the sound that the sewage manhole will produce is very, very loud, and sometimes it will cover the entire leak noise. And the third one is the noise, leak noise under the factory. So this is more a simple situation, because from the sound, the leak noise is very clear compared to the factory noise, and I can tell that the factory noise is probably from the excavator, because you can hear the excavator is driving around. But in a real situation in China, we have almost every day there are some detection work in the factory, and those factories will not close down their machines. So the machine's noise is from 24/7, 24 hours non-stop. So when we detect this kind of situation, it's very hard, especially for the new leakage technicians. So there's one way that we use when we do in the factory, is that either we can choose the leak noise correlator if there are enough pipe accessories for you to use the standard sensors, or by your experience, because the leak noise will create a certain pitch, and at this pitch it's different from the factory. Then you are able to find the leak point. But if the leak point, the leak noise, the frequency is as the same as the factory produces, then I suggest you to use the leak noise correlator, or you can use the tracer gas method to detect from this situation. So the last one, I'm going to show you a proper leak noise that picked up by the ground microphone. Right, so this is a very interesting sound clip, because if you listen carefully, the loudness of noise, it's from very, very low, very tiny, and it's getting closer, louder, and then finally it will reach to a loudest point, and you can actually hear the water jet from the hole. And then when the technician is work across the leak point, it's getting lower again. So if you are familiar with the leakage detection work, you can image a peak value or a peak curve immediately from listening this sound. So it's very clear that the closer you're getting to the real leak point, the louder you will hear from your headphone. So this is very interesting sound clip. So the second part, after talking about some basic knowledge of the leak noise, we're going to present some conventional methodologies and tools, and also some unconventional method we've been used in China. So the leak detection work in China can be tracked back in 1970s, and then it's the most professional, or what we can say, like the official leak detection work really started in the early 1990s. So before talking about the conventional methodologies, for every water leak detection work we have in China, we always follow the 3 steps. So it's the area survey, find the leakiest area, of course, and then the line survey. So from an area, we shrink the range to 1 pipe. So we find all the leaky pipes, which pipe is leaking. And then at last, we will focusing on the point on the pipe. So it's like a zoom in procedure from the big area from the big suspicious area to 1 suspicious point. And then we use the special way to pinpoint the leak and then fix the leak. So for each step, there are going to be different tools. So for example, for the area survey, how to prioritize the highest possibilities of one leak area. So we can use the DMA, we can use the water balance, we can use the noise loggers, and we also can use the multi-parameter sensors. Like you can monitor the water flow and the leak and the water pressure, and also the temperature in the same time by use those props. So for the line survey, it's going to be the same as also the other countries use. We will use the metallic pipe locator or the non-metallic one to reclarify the pipe, the bureau depth of the pipe, and how the pipe runs in the area. We will use the metal locator to find if there's any buried water meter or valves, because in China we have lots of construction every day. So sometimes when people excavate the entire area, when they pull back those soil, they maybe forgot there's a meter or there's a valve in there, so it just buried. And when the time goes by, those valves and water meters will get broken. And if this branch line or this branch pipe is not closed, then the water will come out. So it will automatically become a leak. So it's very important in China to find those missing valves or buried valves before the detection. And then of course the manual listening stick everybody used in the whole world. And to find the leak point or to pinpoint the leak, we're going to use the ground microphone, and we will use the leak noise correlator. And the boring bar method it's probably the special way in China and also in Japan, because I think it's the first country use the boring bar method, and then we learned that method in early 1990s and started using in China. I will talk about more during the boring bar slide, and also the boring bar will combine with the listening stick together to pinpoint the point. So for the area survey, we have tried the very classic lift and shift for the noise logging method, and it's still using in China at the moment. So we basically install all the loggers on the pipe accessories. We drive a car, and then we use the special receiver to receive this noise values, and then we go back to the computer and to see which area is red or yellow or green. And then we see, okay, this area is having a leak alarm, and then let's go and check. So it's good that when you have a relatively small block, like in Japan, to use the lift and shift, and also in the UK, or maybe in Singapore and Thailand, it will be very convenient for you to use the lift and shift because of the entire water demanding area is smaller. So you can easily get those data by driving a car or something else. But in China, it's different because, for example, in Beijing, we used to deploy 3,000 loggers back in 2008 during the Beijing Olympic Games. But that only covers just around the Olympic Stadium. And for the entire Beijing city, maybe we need 100,000 or something, or even more to cover. So considering the cost and also the driving situation in Beijing, you know, the traffic jam. So we tried the classic ways for many years, and we finally realized that maybe the traditional ways is not really suitable for China. So we developed our own smart method. So it's similar. We have the logger here, and we use two ways. We have an NB-IOT, or the narrowband Internet of Things. We have the base, so we can use the base to transfer the logging data back into the computer. So there's no people to pick up those data. Or we can use the LoRa to get the data, and then it will automatically showing on your pad or your iPhone. So both ways are trying to saving more time, and also it's good that so we don't have to drive every day to pick up the data. And as far as I know, that in the world there's already some other manufacturers producing the NB-IOT type of loggers. But to be honest, we have developed the NB-IOT loggers 3 years ago, but it's just not really promoting in the world. We're trying to do our own trials in China, and it works quite well because we have a comparison between the classic loggers and also the new developed smart loggers. So the smart method it's now quite famous, or quite a hot spot in China for all the water utilities. Everybody is trying to use the 5G network because it's faster, so and saving more time to receive these noise logging data. So when we define an area of a leaky area, then we have to zoom into the pipe section. So we use the listening stick, the manual listening stick. We use the listening stick to put it on the water meter. We put it on the fire hydrant. And sometimes when in China, especially in the north and east area, we have a very deep manhole. We have to use the ground microphone with a special magnetic pickup sensor. So we have a extended long wire to put the sensor into the manhole and to listen. Or we can use the extended listening stick. We have sometimes 4 meters long listening sticks to specially design for those ultra deep area. And also the electric listening stick also as well to listen on those water meter and other pipe accessories. So when we find the pipe section, then we have to use the ground microphone. And in some area in China, the water utilities, they don't use ground microphone. They use listening sticks and leak correlators. They don't really trust the ground microphone. But the ground microphone, it's actually very useful, and it's also frequently used in China. I can guarantee 99% of water utilities in China will have at least one ground microphone to do the survey. So the whole purpose of using the ground microphone is to pinpoint the leak point. So usually in the night operation, and for different pipe materials, the pickup point on the pipe is different. So for example, if you have a PE pipe, the pickup point between each other, it's about 50 centimeters or even shorter, or maybe 30 centimeters, because the noise propagation distance is very short. And if you have a steel pipe or you have a galvanized pipe, then you can walk longer, maybe 1 meter or 2 meters at each point. So when we use the ground microphone, and it's also need to be aware that during the rainy days, the raindrops will have some impact on your listening efficiency. So it's not recommended to listen under the rainy or drizzling or of course heavy rains is not possible. And also if you have a sudden change in the pipe bearer depth, so maybe you work on a 1 meter pipe and then suddenly it goes to 2 meters, then there is going to be a sound created in that area. And also if there's a big pipe coming into a small pipe, then in the junction section, then there's also be a noise created. And also for each pipe materials, the filter we're going to use on your main unit is different. So as you can see from the table in the right bottom corner, for the CIP pipe, we usually use 200 to 800. And for vinyl pipe or plastic pipe, we use 100 to 800. But in the real situation, we usually use 400 to 600 hertz to find the PE pipe. So for every pipe materials, you have to, before you start doing the listening work, you have to choose the right filter to cut it off the other background noises, and just to keep the right noise you want to hear.
它力度非常过来，尤其这种高速管哦，高速管的它的漏点是管很浅，关的这个强度也很快，所以说流动这种会很快出现。
Right. So the video clips I'm showing you now is a normal speed of a proper Chinese leakage technician when he's doing the survey. It's not a show off. It's just the normal speed when the technician is so familiar with the area and also the leak noise. So he will work very fast to listen the leak noise using the ground microphone. And also you can hear the dog barking. It's so common in China at night. So I guess the technicians are so familiar with that. So you can hear me just chatting with him, and then it's okay for him, and he just walk and pick up the noise for 1 second and then just walk along. And the pipe material in this video, it's a galvanized pipe. So he probably have more confidence to hear it. So the other type of pinpointing the leak location is to use the leak noise correlation method. And this method has been developed since 1970s was originally designed in UK, and then the rest of the world start learning this method. So it's a very good method, but only when you have the correct pipe information. For example, you have to know your pipe diameter, you have to know the distance of the pipe section, and you have to make sure the noise can transmit to the two centers. Otherwise, there will be a non-successful leak correlation. And also, when the situation where we use leak noise correlator is when like the pipe, it was a building sitting on a pipe, and if there's an ultra deep pipe, and if there's too much noise, too much background noises in your detection field, then you can use the LNC method. So there's one tricky situation when we refer back to the as you can see the bottom diagram here about the correlation peak. So for every type of LNC device, we will receive a correlation peak. And sometimes when we excavate, we will see a dry hole. And then that's the situation when you will see a fake noise or a fake peak. So this situation always applies on sometimes like the T-junction, and sometimes it's there's some blocks in the pipe, maybe a wooden or a rock or something in the pipe to create this noise. And sometimes is the unknown valve or unknown branch pipes under the ground. So in China, when we do the leak noise correlation, I always suggest the water utilities to use the pipe locator to reclarify the underground buried properties, and to see if there's any old pipes or old branch pipes or other things that can create similar sound as the real leak sound to give you a correlation peak. And sometimes the fake peak, it's so clear, and you actually can see two peaks on the screen, but there's only one peak is real, like the real noise. The other one is the fake one. So the boring bar method, it's all especially applies to in the northern part of China, from Shandong province or Henan province, and to Beijing, and going to the eastern side to the eastern China. And some of you might know that in the northern eastern China, the pipe burial depth can be as deep as 5 meters or 6 meters. And so under this kind of situation, even you use the leak noise correlator combined with your ground microphone, sometimes still not sure if the leak point is there. And also because it's so deep, when we use the when we do the excavation, we will spend more time and more labor force, and we have to dig a very, very deep hole. So considering all these situations, we decided to apply this boring bar method. So the purpose of using the boring bar method is to minimize the excavating area as small as possible. The reason why Japan is using this method is because, you know, the Japan, the block area is very small, right? They have a small street, and so it's not like in China, you find a point and then you excavate like 40 by 40 centimeters or even larger area. In Japan, it can't work like that. So they developed a method that can minimize the area so that to save more time and more labor force. And this is also applies in China, especially when in those deep area. When we find the point or the suspicious point, but it's not confirmed, we always use the boring bar method to confirm that the point is actually the leak point. So when we drill a hole, and then we will put our listening stick, like in this video here, we put the listening stick into the hole, and then we will listen by our ears to hear that. Sometimes if it's right on top of the leak, we can even hear the water jet with the water jet is pushing the stick, and also we can hear the small rocks and soils is flowing around. And also there's one caution when using the boring bar method is we have to clarify that there's a pipe or electricity or telecommunication or other things around the pipe, so that we don't have to break it. And I think last year I asked some of the professors in Europe. They said they don't have this boring bar method because it's illegal to make a hole on the street. So it's, you can see the difference. But in China, it's okay to make a hole, because if you don't make a hole, you might miss out the point. And if you miss the point, and then it costs a lot of money, time, and labor. So here, this is the boring bar we have here to make a borehole on the street. So just let me show you. So this guy is almost done with the boring bar method. Originally he should stand up and then use the boring bar to push it down to get a hole. And just bear in mind that when he do this procedure, he knows how deep is the pipe. If you don't know how deep is the pipe, don't use this method, because you're gonna break the pipe immediately. And so the second one is when we complete this the borehole, and then we'll put the listening stick inside the borehole. Let's just check. Right, so just give you an idea that Chinese word is called leak in the background. And you can see the listening stick is shaking under the high water pressure. So this must be a leak point, and also it's on top of the leak point where you got the loudest noise. And you don't even have to put your ear on the listening stick. You can already listen by the phone when he doing the video clips. It's so loud that you can't miss this point. So those four methods are the typical methodologies we use in China to find a point. And in the same time, we have also tried different unconventional detection techniques. So the first one we tried is the Sahara. And Sahara, the first time I heard it's back in 2015 by the Pure Technologies. And they done quite a few case studies in China. And this is one of the case studies in Shenzhen area. And you can see they've done 4 lines and totally took about 2.2 kilometers total length. And the result is they didn't find any leak point, but but they found a couple of butterfly valves and some blockage by this method, Sahara. And also at the same time, they tried smart bore. They find they find a couple of leaks. They find 2 leaks, and there's one leak is a simulated one, and they find it, and they find some airlocks or the gas bag or the airlocks. They found a few of that, and this is also a very huge pipe. Let me see which. It's all right. It's a 1400. It's DIN 1400 water mains. So they did a trial on that and find two leaks and a few airlocks. So they also tried the helium gas. The helium gas is different from the traditional tracer gas, as we know, like the mixed up with nitrogen and the hydrogen. So I'm not sure why they use the helium gas, because as far as I know, the helium gas is very expensive. And they did a trial, and the good thing is they find a leak on a 200 pipe. It's a 10 meter cube per hour. But as also you can see from the slide, their result, it's not suitable for urbanized area, because first of all, the cost of helium gas is very expensive. And also, as you can see from the live diagram, there's too many holes. There are like 7 or 8 holes in this small area. In order to release the helium gas on the ground, they have to make 8 holes. And personally, I think it's totally unacceptable to do a leak detection like this. And also for Saharan smart bore, it's the same issues. First of all, it's the cost. I'm not sure how much money the European water utilities will spend on doing one smart bore or Sahara project, but in China it's very expensive. And to spend that amount of money and find less than 10 leaks is, well, I can say the water utilities will not really accept that. And also the preparation work in China, especially for Sahara, it's complicated, and you need very well trained engineers to do this work, to perform a proper Sahara detection activity. So it's not like selling a device or something that you can do a little training and then they will get used to it. For Sahara, for smart bore, it's totally different. I think it's a higher level technique in China, but it's still working, because in some very large diameter, like DIN 1000 or even bigger, there are some points that is on the highway, or it's in a very, very crowded area that you cannot cut off the road, because the cars will have to driven by. So then that you can use the smart bore or the Sahara. So it's also has its own situation, suitable situations to use. But generally, if you treat the Sahara or a smart bore as like a conventional method, I think it's still not going to work. But in a large diameter, I suggest you can use that. So finally, is the satellite. I've been reading some papers on the satellite technologies. You know, there's one company in Israel and there's one in Australia, I think. So they both using the satellite to detect the differences between the soil and the I forgot what's the term for that. But as long as you got water on the ground, on the surface, you will have a POI, point of interest. So this method is totally a new idea, because they don't need DMA, and they don't really need to send people to do some kind of survey, because the satellite can do everything. But also there's some issues about the satellite. Is first of all, the range of the satellite, it's still too big. As far as I know, it's 200 meters as a radius. And so when you have a radius like that, you still have to send people to, you know, to walk around and do the survey and try to find the leak points. And the second one is again the cost. The cost of a satellite is also a little bit high in China. And the third one is, as you can see in the diagram here, the satellite does find leaks, you know, 2 leaks in the radius, but the most of them, the leaks are actually the leak from the valve or from the meter. And in China, it's interesting that we treated those kind of leaks are not really unreported leaks. And what the water utilities really want is to use the satellite to find unreported one, you know, just like the one on the street, and there's nothing, there's no evidence. And there's some people argue that, okay, you still got unreported leaks because it's hiding inside the manhole. But in China, no, it's not unreported leaks. It's another type of leak. So this is very interesting situations in China when we still doing the satellite technology. But it's good because for example in Beijing we have already had one trial project, and now I think they're going to have another one in this year or the year after. So in China, I think there are more tricky situations than any other countries, because we have a large population. We have lots of construction work. Our street changes every day. We always see sometimes poor construction work. So and also the background soil, it's not that high quality. So we have more tricky situations, and I'm going to show you some 2 or 3 tricky situations we have, and also it's very, very hard to find the leaks. So large diameter, as I mentioned, it's tricky because the noise will not go very far. So for this one example, we have a 1000 reinforced concrete pipe, and it's relatively deeper. It's 2.5 meters. The reason I use this case study is not only because the sound propagation distance is short, but fortunately we have 2 pipe accessories on the water main, so we can use the leak noise correlator. The tricky part is there's a gas line running parallel, only 20 centimeters apart from the water main, and theoretically this doesn't make sense because it's too close and it's dangerous, but that's the real situation here. And so before we almost started excavation, but then I told them that, okay, you have to you know, use the pipe locator to swipe again, you know, to find if there's anything parallel. Otherwise you can't use the boring bar method, because maybe you will drill a hole on the gas pipe and then, you know, explosion. And yeah, so it does. And you can see the 2 line here. This is actually the gas pipe line here, and here is the leak right down there. So you can see how close the main pipe, water mains, and the gas line. And this is the big point here. very tiny leak point. So this is like how important the you have to know what's buried underneath near your water mains. Otherwise, it's going to be a tragedy when you doing the boring bar method, or even excavation directly. You will break the gas line, and then bad things happen. And we have a ultra deep P pipe. It's 8.1 meters. It's, believe it or not, it's really 8.1 meters deep. And we also have a 7 meters deep P pipe was found before. And why it's so deep is because of the backfilling of the soil. They dig out the road and then backfill the soil and then dig out again and then backfill. Several times of construction works. So that the road is getting thicker and thicker and thicker. So your pipe is getting deeper and deeper because you got too much soils on top of it. And the worst situation is this P pipe doesn't have any tracer wire or any other traceable probes on the pipe. So basically we lost the pipe. We actually lost the pipe, and we can only see something or get some idea through the manhole. So the first thing to find to get the leak is to find out the exact location and build depth of the pipeline. So we use the copper wire with the signal rod, or we can say it's a sound, and then to make the entire pipeline traceable. So we know, okay, we are working on the pipe right on top of the pipe, and then we also know, okay, this is 8.1 meter deep, very deep pipe. So it's going to be hard to find a point, to pinpoint a point. And then how was the leak point was located is there where we use the pipe locator, and to trace as long as the signal the sound is going down, we trace it. And then there's a sudden drop on the gain value, or we can say on the receiver there's a peak value is suddenly drop off. And then that's one of the suspicious point we can check, because usually if the pipe is a continuous long pipe, the signal should be continuous. And if there's dislocation of the pipe, then there should be a drop on the signal. So this is where we find the point. And then we use the proper ground microphone method, and we use the boring bar method. We put a very long listening stick into the hole, and then we find it. And it's a 110 meter cube per hour leak. And yeah, and you can see from the pipe here, it's just located. So in the normal situation, we don't really need this kind of deep pipe. Usually we have is between 2.5 to 3 meters and less. But in the northeast area, we have lots of like 4.5 or 5 meters deep. So we usually use the tracer gas, or we use the LNC method to detect. But I didn't really include that into this point because of the time. And the last one is the pool leak. And thanks to I think it's Mr. Malcolm Fowley, explained this term to me, because I don't know the English terms, like how to describe this kind of leak in English, because in China we call it mute leak, or we call it pipe surrounded by the water, but it's called pool leak. And yeah, and you can tell from the term it's a leak from the pool, so you don't hear anything from the situation. And this situation is probably the trickiest situation we have as a leakage technician. So how does the leak point, pore leak is occurred is when you have a low soil porosity or in a more muddy area. When you have a leak point and the water jet will come out and it will not going through those soils because of low porosity and permeability. So you actually create a space which you can contain all these waters in one area. So in the end, it's going to be like a pole around the pipe, and then you won't hear any noises. So it's almost impossible to use the conventional method like the ground microphone acoustic method to do it, because you don't hear anything, and so those devices are probably not going to help. To solve this problem, we have one way to do it. We can close the front and rear valves of the leaking pipe, and then we'll wait that the water in the pipeline and bodies surrounding the soil, and then when it all goes through or all absorbed by the soil, and then we reopen the valve. And at the same time, we use the detection team to use the acoustic method to pinpoint location, because when the hole it's got no water, and you reopen the valve, so that at this point of time, the water jet will impact on the soil as the usual situation, and so that's when you can do your proper acoustic method to find the leak. And the other situation is when you know the approximate range of the leak point, and you can use the boring bar to make several holes on your pipe section, and then you insert your leak noise correlator probes to combine on your listener stick, just like on the right diagram. And then you use the machine to help you to analyze where the point is, where the leak point is. And also you can try done by yourself, like me. You can combine your ground microphone with your listener stick and try to listen to find the point. So pore leaks, it's a very interesting topic. I'm happy to discuss with all other technicians around the world, see like, is there any other better ways to get, to solve the pore leak. This is a very painful situation when we have during the detection work. So at last, I'm going to talk about two case studies. One is the ALC one, and the other one is the PVC one. The reason I didn't put too many case studies on the water loss management and the ALC, because there's going to be other of my colleagues and other Chinese professionals will talk about more on in the managed level regime, about how to control the entire the leak rate and NRW rate. So just give you one example from Xiamen Water. Just like what we have done from other world, we use DNA to find the highest possible leak area, and then you can see from the table here, we have an increase from the minimum night flow. And then the water company will send out 60 detection teams for surveying and detection. And for each team, we'll have 2 or 3 persons. They usually walk averagely 3 to 5 kilometers per day. And the plan was to survey for over 100 pipes for 2 days and smaller pipes for 3 days. So finally, they found a circular break on the DIN 100 cast iron pipe, and the leak rate was 150 meter cube per hour. And when it fixed, the total NRW dropped 2%. So this is quite a typical active leakage control procedure we have. And what's more interesting that is they have an outdoor physical loss test field. Why they have this test field is because they're trying to quantify how much water loss from each leak point, and throughout different fractures and in different pipe materials and even in different pipe diameters, so that they can try to analyze the water volume lost from each leak point, and to see which point it's getting more water loss and which point is less. So this is also a question for all other technicians, because in China we don't really have a proper way to calculate how much water loss from the hole. We have an equation, but that equation always gives us a much higher water loss volume than we actually estimate in the field. So if any of you have better idea or better method to calculate the water loss, happy to discuss that. So for the performance-based contract, as far as I read from the IWA guideline, there are actually 4 types of PVCs, and in China we don't really have the first one, which is the longest one, like a year to 1 year, and then we source all the professional technicians and try to help water utilities. We don't have that complete one. We usually have the quickest one, like we sign a contract, we find a leak, and then we get the money back. Depends on how much water we saved. So most of the time, we actually do this sort of PVC case studies in China all the time. So for this case studies, it's the one I'm just talking about. It's a 1-year PVC contract. It's from water utilities in Shandong province. And again, the project area was designed into 3 DMAs and is monitored on a specialized software platform. And the results show some minimal night flow in DMA1, increased about 150%. And also the daily water usage is about 85% of increase. So a highly possible leak was here. But when they sent out the detection team, they have several issues to be considered. First of all, the local water pressure was less than 0.15 megapascal, which is in China it's ultra low pressure, which is hard to find the point because there's not enough pressure, there's not enough noise. And also when they try using the leak noise correlation method, the distance between 2 pipe accessories, it's more than 2 kilometers away. And we actually have a cement pipe there. So it's impossible for a leak correlator to transmit the leak noise into 2 probes. So, and we think about the unconventional method, and as the detection field was surrounded by the crop farmlands, so we couldn't apply it. Then based on all those situations, in the end, we go back to the basic. We use the classic listener method, the ground listener method, and plus the boring bar method to, point by point to find the leak out. And fortunately, the technician who did this work, he knows the area very well, especially how the pipe goes. So it was a one-night job, and then we found the leak. was a leak on the junction between the 400 main pipe and DN 160P branch pipe. It was a huge crack was found, as you can see here on pipe. It's probably due to poor pipe installation. And then after the repair work, the minimum night flow was decreased from 103 to 77 per hour. And by rough calculations was 240,000 meter cube can be saved annually. And you can see, we have a very cheap water price in China. We can save, this 744,000 RMB of money from each year. So which is quite good. As for this is for only DMA1. It's not a year. So it's a quite effective job to be done. So this is it. This is everything I would like to present to everybody. And as you know, this year we have a virus situation, and we were planning to have a water loss event in June, but unfortunately, because of the coronavirus, we changed to November. So if any of you are interested in attending this meeting, it's in Shenzhen, and if you would like to discuss with others, if you try to know more about the leak detection and methodologies in China, or want to see me and to have a cup of coffee and chat, welcome to attend this meeting. It's in November 8 to 11. It's in Shenzhen. And in the end, I would like to say I do hope everybody can be safe at home, because it seems like the coronavirus is not done yet. In China, we're about to control it, but still we have sometimes we have some new cases coming up, and especially for America and for European countries, it's still going on. So please take care, and please do wash your hands and wear the mask. And thank you very much. No.
Thank you, York. That was very good. We do have some questions in the chat group, so maybe you could go through that and just see which ones you can answer.
Yeah, let me check. So I have found that it's the pipe wall thickness that affects the leak noise. As your noise gets, it's a comment from this side. Okay, it's a comment. How many hours did it take to get this leak? Which leak? Sorry.
Maybe you can. The person who asked the question can say which leak it was that they were after, because you did talk about a few, and maybe they were one at the time.
Let me just.
The 8.1 meter deep.
Oh, right. It took about 3 nights to plus 3 days and 3 nights to find this leak. Was almost impossible to find it. Well, before we try use the sound, the tracing wire method, we just tried. We didn't really expect to find it, because if we couldn't find the leak from the pipe, we're gonna just cut it off, the entire pipe, just leave it, and then we trying to get another new route for that. But fortunately, we find it because the leak rate is not that small. So and also there's the signal of that drop was quite clear. So it's a combination of luck and also the profession of the water utilities. Okay, so next one. What does me thinking are the best options in the future for leak detection? Will satellite technology improve? Are DMA still be best, or are correlating lasers for China? It's from Mr. Stewart. Yes, the satellite technology will definitely improve, and as far as I know, it's improving from 200 meters radius to now 50 meters in radius. There's some guy from China told me about that. They have improved the technology to make it the circle smaller and smaller. But in the same time, when we use the satellite in China, I didn't mention during the presentation is that, especially in those areas with high water table, and for the areas with lots of rains, with lots of seawater, you know, the coastline countries, they are still hard for satellite technology to be applied because of the physical differences between the seawater or the underground water and the water from the water mains. And so for those cities, it's hard to find it. You will see lots of POI probably, or lots of dots saying that, oh, there's a leak. But actually it's not a leak. It's probably from somewhere underground coming up. But still, because of the water from the water main and the sea waters, it's still different because of the chlorine. But it's still hard for them to use the satellite in this kind of cities, and also the cost. Because you know, if you buy a leak noise correlator, it's still cheaper than you use the satellite, because when you use the satellite, you still have to use your labor force to find it and to buy more equipment. And so the manager level people in water utilities will think about, okay, maybe if we buy devices and we use the team to find it, it's more efficient, it's maybe less cost than use extra cost for buying those, you know, satellite services, just for now, I mean. But if the radius can be smaller in the future, then it's definitely going to be a very good option, because some of the area they cannot use DMA, or there's no much time, or there's no much profession in there to do the DMA project. For China, DMA is still the best. I think DMA, it's becoming a common tool. I don't think it's going to be a best or not best. It's common. We have some paperwork from the government saying that, you know, the DMA has to be applied or has to be used, at least tried, for every water utility. So it's more like I don't know, it's like compulsory or government recommended techniques for DMA. So whatever it's best or not best, the water utilities will use or will try DMAs as their priority. And also the lots of companies in China, manufacturers and those software companies, smart water companies, they're always promoting DMAs as their first option. And DMA is always combining with correlating noise loggers too. We don't have many correlating noise loggers in China at the moment, because when Mr. Stewart mentioned about correlating loggers, it's different. When the one we have in China now, it's just leak noise loggers, but with NB-IOT technologies. But they can't really correlate, or they can say they correlate, but you know, it's not like the typical LNC we used in the conventional way. So I guess correlating noise loggers are more efficient. I can feel like it's more efficient, because if you just think about it, if you increase the number of probes from 2 to 30, and then you're correlating all the time, which means you will find all the leaks probably in the same time. And if that's the case, well, why do we have to use DMAs? I mean, DMA is a way of finding an area, which areas got more leaks. But if you spread entire correlating loggers around the city, then you will find leaks probably just one click from the pad. So I guess correlating noise loggers, if the cost is sensible, the water utilities will also try that too. But for now, the common combination in China is we have DMA and we have noise loggers combined together. Because if you only have DMAs, it's okay, but maybe it's not really that efficient. But if you have the noise loggers, it helps. You know, DMAs, it's monitoring the flow and pressure, and noise loggers monitor the noise. So we have like 3 parameters monitoring the same way. So it's still like a combination of 2, or maybe some water utilities that have spent their money on building a DMAs, they don't have much money to buy noise loggers. So I think both 2 are equalized. I don't know which one it's better. It's all depends on, you know, how much fund the water utilities is going to invest, and also the water supply, the volume of water supply they have. Okay. The low and middle income countries where the supply is most intermittent are rarely accurate, and there are so many chances of not having serious doubt, if any. How best can we find in such a situation? So, okay, network maps are rarely accurate. We have the same situation too, especially in the county level water utilities. Basically, all the maps are old. It was on the paper. It was, you know, it was just chaotic, and the worker who wrote this map has been retired like for 20 or 15 years ago. And so for this situation, I suggest you to find an engineering company to swipe the entire area first, or the area you want to do a leak detection first, to get clear, like how many pipes is underground, and what's the direction they're going through, and what's the bureau depth, and what's the pipe materials. Because when you have those situations, those information, it's better for you to conduct a leak detection activities. If you don't have those activities, you will have all kinds of serious doubts every day, and it's going to be so depressive. I mean, I had these situations before, like in the Shandong province, when we had to do a field training for water utilities, and they just brought us to a living district with all PE pipes buried underground, and they say, okay, you can start doing a leak detection. I'm like, how? I said, do you have the map? Do you know where the PE pipe runs? He said, no. I said, okay, I will not do this training tonight, because you have zero information, and unless you bring a dog, maybe that could work. Otherwise, there's no way you can find a leak without knowing any pipe information. So I suggest this gentleman to, you know your pipes and know how the pipe runs, to get all the clear information underground, and then started to do a leak detection work. Otherwise, it's going to be so depressive, and it's wasting your time and money. Okay, there's the orifice discharge equation. Yeah, I see that. Just to share, right? That's the smart rule case studies. Can quantify correctly? Yep. Can do. I don't think noise logger can do real unless I have time. Yeah. That's what I about to, was what I saying. The noise logger, it's just a noise recording device. They don't have the synchronizing time lock in the device. Well, there is some manufacturer already developing those kind of correlating loggers, but just in terms of the cost again, because in China everybody see the water price. It's 3.1 RMB, which is about, I don't know, 0 point something. But yeah, it's cheap, and so water utilities don't have much money to equip with better devices. So what we usually basically do now is still as the same as back in 10, 15 years ago, to use the labor force, use team, lots of labor force. But now it's good because we have more noise loggers help us, the smart one, to saving more time, so that our technicians don't have to run every street every night. So we can run through some certain street to do this. Right. Any more questions? Did I miss some questions?
One other thing, York, about the time synchronizing for noise loggers is that a lot of people use the GPSs. So if the noise loggers have a SIM card inside with a GPS, then they can link with the satellites, and that's how they do time synchronization now, which is how all of the correlating loggers work.
Okay, you mean the 4G SIM card? Yeah. Okay.
There's one more question just come in from Ian.
Yep. Have you tried using hydrophones that installed? Yes, we've been using hydrophones. It's interesting. Back in 20 years ago, the hydrophones has been already introduced to China, and then for that time, because our fire hydrants is not that developed, and the knowledge level of water utilities, they don't really understand how the hydrophones is going to work. So I think starting from 2 years ago, hydrophones come back again, this theory, and yeah, it's quite, especially in the southern side of China, quite a numbers of water utilities, they use hydrophones, but they don't use every time, because it's going to take some time and work to install on the valve, especially when they are detecting leak points on the large diameters, from 1,000 to above. They will use the hydrophones. Yes, so we have quite a few case studies on hydrophones. Okay, so for plastic pipes, what method is the best? Well, believe it or not, in county level water utilities in China, we have some area, we have 85 to 95% of all the pipes are built by, are composed by PE pipes. So for plastic pipes, if it's a shallower pipe, I say, okay, you can use the ground microphone, because the PE pipe, the sound propagation from the PE pipe is like a double-sided sword. Why I say that is, although the sound propagation is short, but in the same time, if you hear the sound, it means it's so close to the leak point, because the sound can only propagate maybe less than 1 meter. So if you hear the sound, the leak point should be around here. For other situations, if it's a galvanized pipe or a steel pipe, the entire pipe will vibrate, especially in the southern side of China. where they build the galvanized pipe only like 30 to 20 centimeters deep, you will hear the noise all the time from the entire pipe. You don't really know which point is the leak point because it's always giving you the same sound from every point. So PE pipe, it's good if you are familiar with the PE pipe detection. It will be easier for you to find it because the sound will not run away too far from the leak point. If the PE pipe is too deep, maybe like deeper than 2.5 meters or 3 meters, then you can use the tracer gas method, and you can use the leak noise correlators. Basically, you use the machine or use the computer software to help you to find the leak. But whatever you use, which devices, as long as there's a hole on the pipe, on the PE pipe, and if you have enough water pressure, there always be a leak sound, unless you have the pool leak. For the pool leak, I think maybe you cannot use the boring bar method to use it, because for us, we can drill a hole and let the water out. Or as I said in the previous slide, you can close the valve and then just get the water all out and then reopen it and then try to make a sound on the point, on that area, the pipe section, and then start listening again. So that's the method I recommend. I think there's no best method for plastic pipes. It's I think for leakage detection industry, there's always changing. The method always changing. In one case, you know, it all depends on the field situations, everything. Okay. Microphone in pipes. Right? I think there are no more questions.
No, I think that's it, York, and I think you've answered all the questions very well. So I'd just like to say thank you very much for the presentation. It was very good, and we've had some good questions. So if anybody wants to catch up with this or see any of our other webinars, they can do so via the YouTube channel. Thank you, York.
Thank you, Gary. Thank you, everyone. Stay safe.